Hi and welcome to this new series of one-shot videos. We are going to start our journey with a very interesting topic, that is sequence series. The reason why I have chosen this topic is there has been a lot of changes in the syllabus of this chapter based on the recent syllabus proposed by NTA, and based on those syllabus a lot of topics got removed. Hence it is prudent that we start from this topic. Also, this is one of those topics if prepared well can fetch you a lot of marks in the exam. So let us start our journey with sequence series. In this one short video, we are going to start with what are the changes in the syllabus. What are the 11 types of problems that JEE has asked on this chapter and how to solve those 11 types of problems and get 100% marks in all the questions that will be asked from this topic. So let us start with sequence series. So let us start with the comparison between 2023 and 2024 syllabus. So what you can observe here is between this comparison, this NT has removed the series part of this chapter. So the sequences is still there in the syllabus, but the series part that was there like AGP, summation, difference, method of difference based questions, those questions will not be asked in the exam anymore now. So with this exclusion, you can see the syllabus has become very simplified. Now we are only going to focus on arithmetic geometric progressions. Even HP is not in the syllabus, and insertion of AMs and GMs between two numbers and relation between A and GM. So this constitutes from problem type basis some 11 types of problems that can be asked. So now sequentially we will go into those 11 types of problems. I will briefly give you the idea regarding what is the basic theory. Then we will go into one of those problem types one by one. The timestamps of the problems are also available if you want to jump on to some specific problems. So let us start with it. So now let us start with the first part of the syllabus, that is arithmetic progressions. Now by definition, arithmetic progressions are those progressions where terms increase or decrease by a fixed number. That is, the common difference is always constant. Now if you look into this part, you can see that these are the basic results that are available to us. If I go into that, the first and the foremost idea is the idea of general term, where we have a formula that nth term is nothing but a plus n minus 1 into t. The sum of n terms, now we can find using this formula n by 2 twice of a plus n minus 1 into t. I don't think that in this video I need to tell you what is a and d. Now if I want to write this formula, another way I can write this is n by 2 into a plus l, where l being the last term and a being the first term. Also, if I want to find Tn using this sum of n terms, that I can use this formula Sn minus 1. If I take the sum of n terms and remove n minus 1 term from it, we are going to get the nth term. And lastly, we have one more formula that is given here, wherein this Tn plus 1 by 2 is nothing but, in this Tn formula, just replace n by n plus 1 by 2. Okay, very used now from JEE point of view. This formula has been used very less. So even if you do not remember this last one, it is totally fine. But first four you should always know. Now this is our first type of problem, that those problems that are based on nth term of GP. Now in order to make it much more interesting for you, what I have done, I have taken those problems that came into 2023 as my first preference, and then 2022 and then 2020 if I want to cover some more ideas. So by just watching this video, we will be able to cover all the previous year questions that have been asked in the last 2-3 years. Now let us look into the first question based on this problem type. So in this question, and in fact any question of AP, there are two important factors to be determined, and those two important factors are the first term and the common difference. So now this series talks about two different types of arithmetic progressions, one in terms of A, another in terms of B. And they have given the value of A1, that is the first term, already as 2. B they have not provided, but that we can find because we have given the value of A10. So the value of A10 in the question is given as nothing but 3. Now using these two informations, let us find the value of D, because once you have got A and D, then we can find the value of A4. So A10 can be written as nothing but A1 plus 9D1. So this is nothing but 3, this is nothing but 2, this is nothing but 9. So from here, if you solve, the value of D1 comes out to be 1 by 9. Now since you have both the values, we can find A4, that is nothing but A1 plus 3D1. Since your A1 is given as nothing but 2 and D1 we figured out to be 1 by 9, this becomes 2 plus 1 by 3 or nothing but 7 by 3. So now in this second part or looking into the second AP, we can find the value of B1 at is it is given as nothing but 1 by A1 from this relationship. So it becomes nothing but 1 by 2. If I find B10, it is nothing but 1 by A10 by another relationship that is given to us. So that can be written as nothing but 1 by 3. And again, if I apply the formula for B10, it is going to be nothing but B1 plus 9 times D2 or the common difference of the second series. Now, if you write this value as 1 by 3 equal to 1 by 2 plus 9 D2, you can subtract and the value of 9 D2 can be written as 1 by 3 minus 1 by 2 and that comes out to be minus 1 by 6. So a D2 is nothing but minus 1 by 54. Now once you have got the value of D2, we can find the value of B4 as nothing but B1 plus 3 times D2 and B1 was nothing but 1 by 2 and this D2 has come up with nothing but minus 1 by 54. If I simplify this becomes 1 by 2 minus 1 by 18. That comes out to be nothing but 9 minus 1 by 18. And if you simplify that, you get the value of B4 as nothing but 8 by 18 or 4 by 9. So now your A4 was nothing but 7 by 3. Your B4 is coming out to be nothing but 4 by 9. So if I want to find A4 into B4, I can easily get them by multiplying them. And it comes out to be 28 by 27. And that, if I look into my options, is nothing but option D. Now let us look into this another question that came in 2022. In this question, they're talking about different arithmetic progressions that can be formed using first term as 100 and the last term is 199. So they have not told us what is the common difference. They have not told us how many terms will be there. These two informations are given. So if I write last term as 199 and let us assume n terms in that arithmetic progression, it can be written as a plus n minus 1 into d. Here n and d both are unknown to us. But now they have given two important conditions for us to figure things out. The most important conditions that they have given is that the common difference is nothing but integer in nature. See, now this is the very important statement, because if I simplify this becomes 99 is equal to n minus 1 into d. And now what they're telling is, see, this part d is also an integer. And if you look into this series, the nth term is actually more than the first term. So the series is increasing. So it is not just an integer, it is a positive integer. Also, this part is a positive integer. So now what you can observe from here is this is multiplication of two integers. And this statement is very significant because this will help us solve the question. So now what all we need to do is we need to write, or we can express 99 as multiples of two positive integers. And that could be the possible values of n and d. So if I do that, so for that we'll have to first write the prime factorization of 99. That is nothing but 3 square into 11. So what can happen is we can take 1 here and 99. This could be one of the cases. Another case could be we can take this as 3 into 33. Another case could be we can write 9 into 11. Another case we can write 11 into 9. Or we can take one more case and write this as 33 into 3. And another case we can do is we can write this as 99 into 1. So here this value that we are writing is nothing but the value of n minus 1. And this value that we are writing is the value of d. So 1 into 99 is different than 99 into 1 because the value of n minus 1 and d will get reversed. Now once you have done that, they have given one more restriction in the question. The restriction is we have to find the sum of common difference. This is the question part, such that the total number of terms are at least 3 and at most 33. So we cannot have terms less than 33 and more than less than 3 and more than 33. If I take my first case that I made here, so in this first case you can observe that if I find the value of n, it comes out to be, this is n minus 1 is equal to 1, so n will become 2. In the next case it will become 4. In the next case it will become 10. So whatever value we are getting here, we are adding 1 because this is the value of n minus 1. And in the next case it will become 12. In the next one it will become 34. And in the next one it will become 100. So what they're saying is you can only take those values for D in which the least term is 3 or the most term is 33 terms. So we can choose this one, it is fine, this one is fine, this one is fine, this we cannot choose, this we cannot choose, this we cannot choose. So corresponding to that, now if you look into this distribution that has happened or cases, this can be the possible values of D that is there. So if I take these three possible values of D and add them up, it is 33 plus 11 plus 9, and this comes out to be 53. Now let us look into another question. This is a little bit more interesting question because it talks about groups of elements and then something regarding the sum of those groups of elements. So if I take an example, what the question is saying is, what they're saying is, if I take, let us say, this set, what is the sum of elements in this set? So what they're asking is 6 plus 9 plus 12. What will be the value of this? Now this you can do in multiple ways. What I am doing is, what I am thinking of doing is, so instead of doing this, let us add the value of the first set into this and then subtract the value of the sum of the first set. So in this we will be able to get the sum of all the elements in the second set. And now this becomes easy also because this part is nothing but a sum of arithmetic progression, and the second part is also a sum of arithmetic progression. So this becomes the core thinking process behind solving this question. So now taking that into consideration, if I want to apply the same strategy, what I will have to do is, first I will have to find the sum till 11th set and then find the sum till 10th set and then subtract them. If I do this, I will be able to get my answer. Now for doing this, we know that if I write all the elements in the sequence in the respective of the sets, it is in arithmetic progression, like 3, 6, 9, 12, 15, 18, 21, 24, 27. This is an arithmetic progression. So if I can just find how many elements till will be there till 11th set, it will be very easy to apply the formula of sum of AP and get to the answer. So now in order to get this, the other challenge is we need to find number of total elements till set 11 and set 10. And set 10 will be important for finding the second term and 11 will be important for finding the first term. Now how to do that? Now if you closely observe, the number of elements in the first set is nothing but 1, in the second set is nothing but 3, in the third set is nothing but 5. So you can see that the number of elements in every set is nothing but an odd number, so it is also an AP. So if I want to find the total number of elements in the till the nth set, it would be nothing but sum of this AP. Again, so what I'm saying is, if I want to find that sum total number of elements till this set, I will have to add 1 plus 3. If I have to go till third set, I will have to add 1 plus 3 plus 5. And if I have to go till 11, I will have to add all the elements or the number of elements in each of this set till 11. And that would be nothing in AP because 1 plus 3 plus 5, you can observe it is an arithmetic progression. So if I want to find an 11, it is nothing but sum of this 1 plus 3 plus 5 till the 11th set. So this can be written as 11 by 2 or twice of A plus n minus 1, that is 11 minus 1 into D, that is nothing but 2. And if you simplify this, becomes 11 square or 120. Similarly, if you want to find n10, it will be 10 by 2 twice of A plus 10 minus 1 into D, that is nothing but 10 square or 100. Now this is the result also. If you find the sum of the odd terms, consecutive odd terms till n, it is always equal to n square for n terms. So that result, if you remember, you can directly use it and then the solution will become even smaller. So if I have figured this out, now S11 becomes a simple job to find. In order to find S11 or sum of all the sets till 11, I can do it by using 121 by 2 twice of A. Now for this series, you can see that A will become 3 and n minus 1. So that is 121 minus 1 into D. Then in this situation would become 3 because now we are considering this series 3, 6, 9, 12. So common difference is 3 here. And similarly, we can find S10 by writing 100 by 2 into twice of A plus 100 minus 1 into 3. Once you have got this calculation, you can do this calculation. you can take this S11, subtract from S10 these two values, and the answer comes out to be 699. The type 2 question is the questions which are based on sum of arithmetic progression. Now let us see a question that was asked in 2023 JEE Mains. In this question, they are talking about S1, S2, S3, S10 be respectively the sum of 12 terms of 10 APs. So they are talking about 10 different APs whose sum of 12 terms are given. Now, whose first terms are already given to us is 1 to 10. The common difference is also given to us. What they're asking is what will be the sum of those sum of 10 terms. Okay. So if I write it down, it is S1 plus S2 up till S10. This is what this notation means. And if I want to write the value of S1, it would be nothing but n by 2 twice of A plus n minus 1 into D, that is also 1. If I want to write the second term, it will be again 12 by 2 twice of 1, in place of 1 of this will be 2 plus n minus 1 into D, that in this case would be 3, and we can keep on writing like this. If we keep on doing this time and time again, what you can observe here is, in this specific case, it is happening in such a manner that I can take a lot of terms common, like this 12 by 2 or 6 can be taken as common. If I do so, what will be left inside? In these two terms also we can take 2 common, and what will be left is this 1 plus 2, the sum of all the A's that are there up till 10, plus n minus 1 by 2. This you can also, not this one, this term you can also observe will come as 11. Let us also take this common. And if I take this common, what I can observe is I can again get the sum of all the D's that are there up till 90. Now, if I do this calculation, what I get as answer is 7260. Okay. And here also, when you're doing calculation, you can observe here you can apply the sum of n terms of AP. Here also you can apply sum of n terms of AP to get the final answer. Now let us look into this next question. This next question came in JEE 2023. In this question, again, is based on an earlier question that also came in JEE Advanced. So in this question, we are going to see what is the basic core concept behind this question. So in this question, if you observe the one term, that is the first term, it is root of A10 plus root of A11. Now, once you have this, you can rationalize it. So if I rationalize it, it becomes root of A11 minus root of A10 by root of A11 minus root of A10. Now, once I do this, what I will get in the numerator is nothing but root of A11 minus root of A10. While in the denominator, what we have got is A11 minus A10. Now, root of A11 minus root of A10 can be kept as standard, and we can write A11 minus A10 in the denominator as nothing but T. Now, once you have done that, you can use the similar format for all the terms. So if I try and complete this series in this new format, it will look something like this. The first term will be written as A root 11 minus A root 10. The next term would be A root 12 minus A root 11. It will go up till last term, that is A root 18 minus root of A 17. And then we have 1 by T outside. So once you have done this, we have come to this point, and now you can see that alternate terms are getting cancelled out. A11 will get cancelled out. Okay. And you can see that if I do this, all the terms will get cancelled out except these two terms, that is root of 18 and root of 18. Now, once we have this, we can simplify this and write it down as root of A18 minus root of A10 by root of by nothing but T. So once I write it down, what I can do is I can find the value of A18, substitute and get the answer. Because we have also been given the condition that A5 is nothing but equal to A7, 2 times A7, and A11 is equal to 18. If I use these two conditions, I will be able to get the value of A, D and all the things and will be able to get the answer. Let us do that. So if I write my condition, A5 is nothing but A plus 4D and 2 times A7 is nothing but 2 times A7 plus 2 times 60. And if I simplify this, it is A plus 4D is equal to 2A plus 12D, or A plus 8D will be equal to 0. This is the first condition that we have got. If I go further, move further and write another condition from the another term, it is given A plus 10D would be equal to 18. So if I subtract this and the earlier condition, I should get the value of D. And if I do that, my 2D comes out to be 18 and our D comes out to be 9. Again, what you can do is using this, if I substitute in the first one, it becomes A minus A plus A into 9 equal to 0, or A is equal to minus 72. Now since you have got the value of A and D, here you can find the value of A18 and you can also find the value of A10. Solve and get the answer. Let us see this new question. Now in this question in JEE 2021, they have used a similar idea of difference of two terms. Now if I take the nth term that is given to us, that is nothing but 1 upon an into an plus 1. We can write the same term as an plus 1 minus an by an plus 1 into an. The benefit of writing this, because see, since the series that they have given is in arithmetic progression, so the sum or the difference of two consecutive terms is going to be d. So what I can do is I can multiply them by an plus 1 minus an, and this denominator term will become equal to d. So this we can write as d and take it out. It becomes an plus 1 minus an by an into an plus 1. And now if I simplify this, this becomes 1 by d times 1 upon an minus 1 upon an plus 1. If I write the whole series using this concept, this is how this series looks like. It will start with the first term. So 1 by d we can take out. The first term becomes 1 by a1 minus 1 by a2. The next term becomes 1 by a2 minus 1 by a3. And it will go till 1 by a20 minus 1 by a21. Till here we can write the whole series. See, once we have written this series, what we will observe here in this question is this alternative terms are getting cancelled out. So all of this will get cancelled out, and towards the end what we will left is 1 by d into 1 by a1 minus 1 by a21. And you should smile after looking into this, because now if I take LCM again, it becomes a21 minus a1 by a1 into a21, and they have given the value of this expression as 4 by 9. We can equate this to 4 by 9. Okay. So after doing this, the next step is quite simple. In our next step, we can observe that the numerator will be nothing but 20d, because a21 is nothing but a plus 20d, and divide by this a1 and a21. Now this is given as 4 by 9. So if I simplify, you get the value of a1 into a21 as nothing but 45. The derivation is the sum of terms from a1 to a21 is equal to 189. So let us also write that. So if I start from a1 to a21, it is 189. So if I apply my formula on the sum of n terms, it is n by 2, twice of a1, and more importantly, we can write this as a first term plus last term. So a1 plus a20 is equal to 189. So what I will get is nothing but 7 here, and this becomes 63, and now if I divide by 7, it becomes 9. So a1 plus a21 is nothing but 18. Now if the product of them is equal to 45, sum is equal to 18, so you can also guess, but if you're finding it difficult to guess, you can substitute the value of a1. So a1 plus 45 by a1 is equal to 18. If you simplify this, this becomes a quadratic. So a1 square minus 18a1 plus 45 equal to 0. And if you solve this quadratic, you get two values of a, 3 and 15. We can consider any value. It will not make much of a difference. Now, after getting this, the next part is to find the value of, see, first term is known now. Let us say that it is 3 in the first case. If I consider a21, so this will become nothing but 15. So a1 plus 20 times d will be equal to 50. So 20 times d becomes 12 since a1 was 3. So d becomes nothing but 3 by 5. This is the value of d that we have got. If you can go into this very simple calculation. Once you have got these values, now your life becomes very easy, because now you know the value of a, you know the value of d, you can find a6 and a16, multiply them and get the answer. So if you do that, your a6 would be nothing but a1 plus 5d. So this 3 plus 5 into 3 by 5 comes out to be 6. And if you find your a16, it is a1 plus 15d, comes out to be 3 plus 15 into 3 by 5. And that is nothing but 12. So if I multiply a6 and a16, the answer is nothing but 72. You can go back to your options and check the B option comes out to be correct. Now, next types of questions are those that are based on properties of arithmetic progression. Now, let us quickly go back to the properties first and then see what kind of question JEE has asked in the recent exams. So if I go back to the properties, the first is basically use these properties of assuming terms. This is the first category of properties. Use only them when the question talks or gives some condition in terms of sum of the terms. Otherwise, this kind of properties will not help you much. And it is not that if you use it will not make it lengthy, it will make much complicated than it should be. So it is very important you keep in point that only use these conditions when sum of the terms is given in the question. Now, the second property says that if you have to assume three terms, then you can assume the terms as a minus d, a and a plus d. So you are starting from a minus d and you're considering the common difference as d. But if you have to assume even number of terms, the concept says that assume those terms as a minus 3d, a minus d, a plus d and a plus 3d. You can see that if you have to add these terms, the d parts will get cancelled out and directly will get the value of a. And that is the utility of using this property. And of course, if no sum condition is given, then there is no point using this, because it is only going to introduce some more minus signs into the question and make your calculations much more complicated. Another thing to note about this even number of terms is here the common difference is nothing but 2d. So this small things sometimes make difference. Next is operations with constant. Now this is very interesting. Like if you have, I will take an example to explain. 1, 2, 3, 4. This is your arithmetic progression. So what we are saying is, if you add 5 to all the terms, so we are adding 5 first. So you can see that what happens is this becomes 6, 7, 8 and 9. Still this is in AP. If you add a constant term to an AP, it still remains in AP. You can see what happened is your first term has changed. Your first term has become 1 plus 5. So whatever constant we added got added to the first term, but your common difference remains same. If you subtract 5, again it becomes minus 4, minus 3, minus 2, minus 1. So again you can see it is still in AP. But the first term has been reduced by 5, wherein the common difference remains same. And if you move further and if you multiply by 5, the same AP becomes 5, 10, 15, 20. Still an AP, but now the first term has become 5 times because the constant was 5. And the common difference has also become, you can see that has also become 5 times. So now both of them are getting multiplied to that constant. And if I divide by 5, let us see what happens. It becomes 1 by 5, 2 by 5, 3 by 5 and 4 by 5 is still an AP. But the first term has been reduced, has been become 1/5 of its original value, and same goes for its common difference. So it is very simple to remember. If you forget, take this very simple example and from there you can formulate the theory and move ahead. So the next set of properties that we are looking into is the properties that are based on means. And now interestingly, when we say means, what does that mean exactly? So if I'm taking two terms, let us see first two terms. So if I am taking, let us say 1 and 3, the mean would mean nothing but the average. So 1 plus 3 divided by 2. So what we are saying first is, if you have two numbers A and B, then the mean would be nothing but A plus B by 2. And now this way is fine. So if I take three numbers like A, B, C, now what does mean would mean? Mean would mean A plus B plus C by 3. If you have more than one numbers, like more than three numbers, 4, 5, 6, 7, n numbers, we have a general formula A1 plus A2 plus A3 till AN divided by. So this is one way of visualizing the whole idea. Another way is something known as inserting means. What does that mean? So that means basically if I am taking three numbers like 1, 2, 3, what would that mean? That would also mean that 2 is a mean between 1 and 3. That is another way to look into it. So the statement means that 1, 2, 3 will be in arithmetic progression. So if you look into this, 2 now can be written as nothing but 1 plus 3 by 2, or 2 into 2 will be equal to 1 plus 3. In other words, if you have A, B, C, we can write this as twice of B will be equal to A plus C. The reason is that I can get this from very simple property, that B minus A will be equal to C minus B. If you simplify, you get this idea. Okay, so this is one way. This is the first result. I have also explained you what does the concept of mean means for 3 terms, for n terms. Now, if you have to look into this mean concept, there are few properties as well. So this was one idea, this is another idea. And then there is this whole idea of the properties. If you have 1, 2, 3, 4, 5, what you can observe is, if you take mean of 1 and 5, that is 1 plus 5 by 2, it comes out to be 3. That is this number. If I take 2 and 4, still the mean remains same, 2 plus 4 divided by 2, 3. And if I take 2, 3, 4, 2 plus 3 plus 4 divided by 3, because there are 3 numbers, still it remains 3. So this is a very useful thing. We are going to use this. And fourth idea is inserting arithmetic means. So now what they are saying is, let us say we have 1 and 5. And I have to insert two arithmetic means. That means I have to put two numbers here, A1 and A2, in such a manner that A1, A2 and 5 are nothing but in arithmetic progression. So now in order to do that, what we are going to do here is, we are going to find the common difference, because A we already know, D if I know, I will be able to tell all the terms. So what we are doing is 5 is equal to A plus n minus 1 into D. So 4 minus 1 into D. So you can see that from here D comes out to be 4 by 3. Since you have this, using this you can find the value of A1, that is A plus D, or nothing but 1 plus 4 by 3. And if you want to find A2, you can write this as A plus 2D, or 1 plus 2 into 4 by 3. The interesting thing to observe here is, when we write A1, it is A plus D. When we write A2, A plus 2D. If I have to write AN, it will become nothing but A plus ND. So again, just to put things into perspective, AN or A1 or A2 is not the number of terms. It is the number of arithmetic mean inserted between two terms. Okay. Now this question says that, and this question was asked in JEE 2023. It says that A1 is equal to 8, the first term 8 they have given. They've also told us that A2, A3, A until AN, these are in arithmetic progression. The sum of the first 4 terms is 50. The sum of the last 4 terms is 170. The product of the middle two terms is, fine. Product of the middle two terms is, this is what they are saying. So here one thing is implied, there are two middle terms. Okay. So now what does that mean? So if you have like 1, 2, 3 odd number of terms, there is one middle term only. But if you have even number of terms, there are two middle terms. So when they say two middle terms, it is already implied that they are going, the value of number of terms are going to be even only. Otherwise, two middle terms are not possible. Now if I move further, what they are saying is the sum of the first 4 terms is 50. So what I can do is I can write it as A plus D plus A plus 2D plus A plus 3D. So these are first 4 terms. It comes out to be 50. This is one thing, they have information that they have provided. Another thing that they have provided is nothing but the sum of last 4 terms is nothing but 170. It can be written as CL, then L minus D plus L minus 2D, and then L minus 3D. You can see that exactly properties we are not using, but something inspired from the properties we are using. Now, if you add them up, and if you add these two equations, what will happen is D terms will get cancelled out. We will get A plus L. Then from second term also A plus L. Like this, we will get A plus L 4 times. And this will be equal to nothing but, if I add 50, this becomes 220. This is what we have got. Now once you've got this, this is nothing but 4 times a plus l, and this is nothing but 220. What I can do is I can divide by 4. So if I divide it by 4, it becomes, and once you have got 55, from here we can get the value of L, because A they have already given as 8. So 55 minus 8 will be equal to my L. And if I do that, and it comes out to be nothing but 40. The question says that we have to find the value of D. For finding the value of D, we will use our first relation. So if I use this, this is nothing but 4A plus 6D is equal to 50. A is already given as 8, so this is 4 into 8 plus 6D is equal to 50. You can solve and get the value of D as 3. Once you have done that, you can move ahead. And now in order to find the value of total number of terms, let us go back to this value of L, or the last term, that was 47. If I take that, A plus N minus 1 into D, it will be equal to 47. Now let us put the value of all the things here. A is nothing but 8 and D is nothing but 3, equal to 47. Again you can solve and get the value of N is nothing but 40. Now if you have done that, what you will observe that since the value of N is 40, there are two middle terms here. The value of the two middle terms now can be written as nothing but A7 and nothing but A8. We have to find the multiplication of these two. So first will become A plus 60. Another will become nothing but A plus 70. And it is not a difficult thing, because we know the value of A as 8 and D as nothing but 3. So if I put the values, I get my answer. Let us go into the next question. In this question, again, we have to insert n arithmetic means between A and 100. So the ratio of the first and the last mean is 1:7, and another condition between A and N is given. So let us write it down. So what they're saying is we need to put n arithmetic means. So if I start with A, then the first one is A1, then A2, and AN, and then 100. These are the things. Another information that is given is A1 by AN is nothing but 1/7, and then A plus N is equal to 33. So these three informations are given in the question. Based on this, they want us to solve this question. If I move ahead with this information, this is a very crucial information. If I use this, A1 can be written as A plus D, and AN can be written as A plus ND as discussed earlier. And if I simplify this one, so you can see that this will become nothing but 7 times A plus 7 times D is equal to A plus ND. Or I can move A on the other side. This becomes 6A is equal to N minus 7 into D. And we also know the value of A in terms of N, because in question they have asked the value of N. So I can also substitute this. So D comes out to be 6 times A, that is nothing but 33 minus N divided by N minus 7. These are the values that we are getting. Now once you have got this D, A already we know in terms of N. So we can write the formula for the last one, that is 100. So it is nothing but N plus 2 term. So N plus 2 minus 1 into D we can write. Now in this formula, A we can write this as 33 minus N. And this term, that is, will become N plus 1, and D we already figured out 6 times 33 minus N by N minus 7. See, now there are two ways to move forward. You can take N minus 7 on the other side, make a quadratic, solve it. It takes a lot of time. So an easier way to solve this question would be to satisfy the options. So as you satisfy the options, and if you clearly observe, only odd values of N would get satisfied. And so it would be more sensible to satisfy these two values first. So if you satisfy, you get your answer as C is nothing but N equal to 23. In this next problem type, we are talking about comparing two arithmetic means and figure out what are the terms that are common between those two arithmetic means. Now, this has been a very prominent question in JEE. So let's see what kind of question JEE is asked and how to approach these questions. Now, in order to approach this question, there is this common algorithm. You have to observe between two APs what is the first common term by observation. So we can write the terms and physically observe and what are the terms that are common, which is the first term that is common. Once that is done, Now observe the LCM of common difference of the two arithmetic progressions. Let us call that it's capital D. And then the last part is all these common terms will also be in arithmetic progression. So that arithmetic progression will have its first term as capital A and common difference as D. Now let us see how this works out. So this question is given, a very straightforward question. Question says that the number of terms common to the two APs, that we need to figure out. So now you can physically observe here that if I write first term is 3, then 7, then 11, so we are adding 4, it becomes 15, then 19, so on and so forth till 407. If you start with the other, it is 2, then 9, so we are adding 7. So if I add 7 again, and it will become 23. And you can see that if I physically match, the next term in my first series might also be 23, so it is matching. So this is first step, figuring out the value of capital A. Capital A comes out to be 23 and needs to be done manually by observing. Now let us come on to the second part. In this second part, if I look into the D1, that is the common difference of the first series, that is nothing but 4. And if I look at D2, that is the common difference in the second series, it comes out to be nothing but 7. And LCM of D and D1 and D2 is nothing but 28. So this we have got. In the third step, what we need to do is we can write the arithmetic mean of all the common terms. So that will be something starting with 23, and then you keep adding 28 to get on the other terms. So we can do that and we can get it. Now what they want us to find is nothing but how many terms will be common between both the series. So in order to do that, always take the series with the highest term lesser than the other. So 407 and 709. If you compare the smaller value is 407. So take that value 407. And now corresponding to this 407, let us find the value of n. So I am applying the formula of a plus n minus 1 into d. Let us put the value of A and D here. So 407 is fine. My A value comes out to be 23 and my D value comes out to be 28. This will become 384 divided by 28 will be equal to n minus 7. And roughly, if you do that, it works out to be n minus 1 is equal to 13.7. 0.7 is not required. If you can just get the integral value, first part, that is more than enough. You can see that the value is coming out to be 14.7 something. So now I also know that n needs to be an integer and cannot be 14.7. So what we are observing here is if I keep on going with this arithmetic progression, how many terms will be there till I reach 407? So what we are saying is 407 is between the 14th and the 15th term. So before 407, there will be 14 terms that will be arriving. Hence, total number of common terms come out to be 40. So the answer of this question is nothing but 40. Now let us move on to the next question. This is a slight variation of the earlier question. Earlier they were asking how many terms are there. Here they are asking what is the value of the eighth common term. So the first step in this question can be easily done just by observation. You can observe this 11 is the term that is constant. So the value of A comes out to be 11. In order to find the value of D, we need to take LCM of the common difference of first series, that is 4, and the second, that is 5. That comes out to be 20. The third one, if I want to find the 8th common term, it is going to be A plus 7D, capital D. And if I put the values, I get my answer. So 11 plus 7 times 20. So that is nothing but 11 plus 140. So it comes out to be 151. Now let us start with this new question. In this new question, very interesting concept they have introduced of common terms is nothing but 3 arithmetic progressions. Now this is very interesting. So what you need to consider here is you need to work a little bit smart. First, find the common terms between these two series. Why these two? Because they have the highest common difference. The first one is nothing but 4. The second one is nothing but 3. And the fourth one is nothing but 5. So I'm considering the one with the highest common difference. You will understand in a minute why. But there's a logic behind that. So once you do that, what happens is here, if I try and write the terms, so here it is also easy to observe the common terms as well, right? So 7 you can easily observe is the first common term. 7 plus, now here this is first thing, and another thing that you can observe is nothing but the common difference. That is going to be nothing, the LCM of 4 and 5, that is 20. So if I take that as 20, the other term, the next term would be nothing but 27, the next term would be nothing but 47, then 67, so on and so forth. Now, since we have taken the common terms of first and third series, now if I consider the common terms of these series, new series, with the second term, I will get the common terms between all the three series. So now, if I consider that, here you can see that these terms, whatever are there, needs to be of the pattern that if I write them, it should be of the form A plus or A2 plus n minus 1 into D2. And what is the specific thing about this? That A2 here is nothing but 2 and D2 here is nothing but 3. So if I subtract 2 from any of these terms, it should be divisible by 3. Only then n minus 1 will become an integer. So that does not get satisfied for first term, second term, but third term is fine, because if I take this as 47 is equal to A2 plus n minus 1 into D2, or 2 plus n minus 1 into 3, and you will get an integral value of n after solving. So this very interesting thing, if you observe in the starting, your life becomes very easy. And now what you have observed is, out of these three series, if I want to write my first step, that is common term between all the three series, that now comes out to be 47. This is the value of my capital A. And if I want to find the value of D, it will be nothing but LCM of this 20 and this 3, that comes out to be 60. So if I want to write my common AP, that would be nothing but 47, and A is equal to 47 we can take, and D is equal to 60 we can take, and write down all the terms. Now interestingly, what they want us to find is not just the AP, they want us to find the sum of common terms, and sum of the common terms that are there in this AP. So if I start doing that, the first term is going to be 47. The next, if I add 60, becomes 107. Next, if I add 60, it becomes 167. And you can see that after this, it will cross the minimum term out of this three series, that is 197. So what I need to find is just the sum of these three terms, and I will get my answer. Now, this next question works on a very interesting concept. What they're asking is, find the sum of all those terms of this AP which are not divisible by 3. This is very interesting. So we can use the concept of common AP to solve this question by writing our first series as 3, 8, 13 till 373, and another series as 3, 6, 9, so on and so forth. The idea would be, logic would be to find the sum of this first series, first one, find the sum of the common terms that is there, and subtract them to get the answer. Because then the terms which are divisible by 3, and that sum if you find and subtract, will get our answer. So this is the logic that we are trying to follow. So for that, we will have to find our first common term, that comes out to be 3 only. So A is nothing but sorted. Second, we'll find the value of D. Now we can see that here the common difference is 5. Here it is nothing but 3. So my D becomes nothing but 15. And third, if I want to find the total number of terms, it could be find as 373 is equal to 3, that is A, plus n minus 1 into, that is 15. If I subtract, this becomes 370 into n minus 1 into D 15. And if I simplify, my n minus 1 comes out to be 370 by 15. My answer comes out to be 24 point something, and from there the value of it comes out to be 25 point something. You can see that there are in all 25 terms that are common. This we have done earlier also. So now what we are doing is, in order to find S1, that is the sum of the first series, we can apply our concept. So let us first figure out the total number of terms in this series. So 373 minus 3 is equal to n minus 1 into 5. And if I do, this becomes 370 by 5 is equal to n minus 1. And this is nothing but 37 into 2. So n becomes 1 plus 37 into 2. And that would be nothing but 2 into 7 is 14, 1. 74 plus 1. So my n becomes nothing but 75. So there are 75 terms in this first series. So 75 by 2 into twice of a plus 75 minus 1 into d. And d in this case is nothing but 5. So you find this as 1. Now we'll find the sum of this series. That is my S2. And if I do that, there are total 25 terms. So 25 by 2 twice of a plus n, that is 25 minus 1 into d, that comes out to be 15 now. And if you want to find the answer, my answer is nothing but S1 minus S2. You can do the calculation and get to the answer. Next, we are going to look into geometric progression. A geometric progression is defined by a sequence in which the consecutive terms have a common ratio into place. So now let us first see what are the basic results on geometric progression. So there is a result for general term, that is nothing but general term of n GP is equal to a into r raised to the power n minus 1, where a is nothing but the first term and r is nothing but the common ratio. The sum of n terms, if r is equal to 1, becomes na. If r is not equal to 1, in that case we can write it as a into 1 minus r raised to the power n by 1 minus r. We can also write as a into r raised to the power n minus 1 by r minus 1. And if the number of terms become infinite, then the formula becomes a upon 1 minus r. Important condition for this is nothing but mod of r needs to be smaller than 1. Now let us look into this problem that came into 2023. This problem talks about a GP with positive numbers. This word is very important. And then what they're saying is, if I take the sum of sixth term, that is ar raised to the power 5 plus ar raised to the power 7, it is nothing but 2. If I take product of the third term, that is ar square into ar raised to, and fifth term comes out to be 1 by 9. And what they want us to find is nothing but 6 times ar plus ar cube into ar cube plus ar raised to the power 5. So I have put the values in terms of a and r. Once I do that, now what you can see is we have two equations, and in any equation of GP, like in AP, a and d were important. Here a and r are important. So if you are somehow able to find the first term and the common ratio, then you can get any kind of information regarding a GP. So let us try and figure those two things out. Now here, if you multiply these two terms in the second equation, it becomes a square r raised to the power 6 equal to 1 by 9. And if I simplify, then the value of ar cube can be written as 1 by 3. I am only taking positive sign because they mentioned it in the question. Now, if you have done this from the first equation or the first information they have given us, we can take ar cube as common. This becomes ar cube into ar square plus ar raised to the power 4 is equal to 2. Ar cube can be written as 1 by 3, sorry. And this is r square plus r raised to the power 4 equal to 2. We can simplify this. So r raised to the power 4 plus r square minus 6 will be equal to 0. So we are getting two values of r square, minus 3 and r square equal to 2. Obviously, we cannot take the negative value. The second value is nothing but the acceptable value. Now, if I use all of these information to solve question, I have two important ideas. One, ar cube is equal to 1 by 3, r square is equal to 2. I can solve further, but it is not required because I can reduce my question into required form. So if I take a common from both the terms, it becomes a square. And if I also take r from the first term and the r cube part from the other one, it becomes r raised to the power 4. Rest is nothing but 1 plus r square into 1 plus r square. Now, since I want something in the powers of ar raised to the power 3, I can take this as a square r raised to the power 6 by r square. And this will become 1 plus r square whole square. Now, what I need to do is just substitute the value and get the answer. So let us quickly do that. So 6 into, this will become 1 by 9. This will become 2. 1 plus 2 whole square. If I simplify this, it comes out to be 3. That is nothing but option D. Now let us look into the next question. In this 2023 question, they have given a very interesting condition that the product of the fourth and the sixth term. So if I take my first term as a and common ratios are, the fourth term becomes ar cube into ar raised to the power 5. And this is given as 9. So what we have is a square r raised to the power 8 is equal to 9. This is given to us. Another condition says that the sum of the fifth term, that is AR raised to the power 4, and the seventh term, that is AR raised to the power 6, is nothing but 24. And now if I look into what they're asking me, they are given this first term as A into 9 term, that is AR raised to the power 8. Second term AR, fourth term AR cube, and ninth term AR raised to the power 8. And then AR raised to the power 4 and AR raised to the power 6. If I simplify this, this becomes A square R raised to the power 8. This becomes A cube R raised to the power 12. The next becomes AR raised to the power 4, and the last becomes AR raised to the power 6. These are the information that are given and what have been asked to us. So now if I look into this very concisely correctly, I do not need to solve equations to find the value of A and R. What I can just do is I can use the value of AR raised to the power 4. Because from that, if I square it, I will be able to get this value. If I cube it, I will be able to get this value. And directly, I will be able to get this value. And if I get AR raised to the power 6, I can substitute in the last part of the question and get to the answer. So in order to execute this, now what we are going to do here is, we are going to find the value of AR raised to the power 4, and that comes out to be 3. Put this value here. If I do that, AR raised to the power 6 becomes 21. Put both of these values here and quickly get to the answer. If I put the values, this becomes 9, this becomes 27, this becomes 3, and this becomes 21. If you add it up, this becomes 60. So it is a very example of one of those questions which involve very intelligent calculations to get to the answers really fast. Now let us start with another problem type. This problem type 6 talks about the questions which are based on sum of GP. So for sum of GP, we have already seen there are two formulas, one for n terms and another for infinite GP. Let us try and apply those formulas in solving JEE questions. So this first question of 2020 is a very simple question, talks about product of terms. Now if you write the first term here, what you are going to get is 2 raised to the power 1 by 4. If you write the second term in the power of 2, it becomes 2 raised to the power 1 by 8. Next becomes 2 raised to the power 1 by 16 till infinity. And if I apply the rules of exponent, it will become 1 by 4 plus 1 by 8 plus 1 by 16 up till infinity in the power of 2. And now you can see that what we have written in this power is nothing but an infinite GP. So let us apply the formula of A upon 1 minus R. And if I do that, this becomes 2 raised to the power 1 by 2 or root 2. That is nothing but our option A. This was a quite simple and straightforward formula based question. Now let us look into another problem. In this problem of 2021, they want us to apply this infinite GP formula multiple times. So if I want to find the value of x, summation notation is used. What does this mean is, this is a series that starts from 1. The second term is nothing but cos square theta. Next term is nothing but cos raised to the power 4 theta till infinity. So if I want to find the answer, it will become A upon 1 minus R, that is nothing but cos square theta. Similarly, if I want to find the value of phi, similarly it will become 1 upon 1 minus sine square phi. Should closely observe what is the value of angle given. Sometimes student will take both the values at theta and then they will commit some error and the answers will not match. If I want to find the value of z, similarly it becomes 1 upon 1 minus cos square theta sine square phi. Now what they're asking is a relation between x, y and z. For finding that, let us find the value of cos square theta from the first part. So cos square theta can be written as 1 minus 1 by x. From here, your sine square phi can be written as 1 minus 1 by y. And now let us substitute both of these values in this last step. So it becomes 1 upon 1 minus 1 by x into 1 minus 1 by y. And then if I take LCM, something, or I open the bracket first, then I get something very interesting. It becomes 1 upon 1 minus 1 plus 1 by x plus 1 by y minus 1 by xy. So this 1 gets cancelled out. If I take LCM, it becomes xyy. X plus y minus 1. Okay. And now I can cross multiply. So this becomes z into x plus y minus z is equal to xy. Or z into x plus y is equal to z plus xy. And you can see that this matches our option 4. Now let us look into the next question. In this next question, they are talking about a very weird kind of summation of GP. They're not starting from the first term. What they're starting from is a third term, then fifth term, and they are going up till 201 first term. And the sum is equal to 200. This is what is the first condition given. And in the next part, they talk about they start with A2, then A4, and they then go up till nothing but A200, and this sum is 100. These are the two conditions given to us, and what they are asking us is tell us the value of the sum from A1 to nothing but A200. Taken all the values at the same time. So interestingly, if you take your first condition, it will become AR square, AR raised to the power 4 up till AR raised to the power 200 is nothing but 200. So if I want to write the sum, it becomes AR square into R raised to the power 200 minus 1 by R square minus 1. We have applied the formula of sum of n terms of a GP. So this is nothing but 200. Similarly, this next series, if you write, can be written as AR plus AR cube, and this will go up till AR raised to the power 199 is equal to 100. And again, the first term is AR. The common difference is R square raised to the power 100 minus 1 by R square minus 1. This is equal to 100. And this R square raised to the power 100, like we did earlier, can be written as R raised to the power 200. Now, if you take this term that we wrote earlier, and if you divide it by this term that we have just got, let us see what we get. So what we get is the value of R. R becomes nothing but 2. Just by dividing my first equation by my second equation. Okay. Now, interestingly, let us look into what the question wants us to answer. They want us to find the sum up till 200 term. If I write it, it is A into R raised to the power 200 minus 1 by R minus 1. Now, if you look into this second equation that we figured out, this is something very interesting. That from here, we can get few parts of this question. And I can manipulate it into getting those parts. So now, if I multiply by R, then 200 minus 1 by R square minus 1. So you can see that I have replicated most of the parts here. Now, in order to get there, I will have to divide by R and I have to multiply by R plus 1. If I do that, I will be able to get my answer. And this part, from this equation 2, I know this is nothing but 100. And R being 2, this becomes 3 and then 2. If you simplify, this becomes nothing but 150. And by doing this smart calculation, you were able to reduce the amount of time required to solve this question and get the answer really fast. Now, let us look into this next question. And this is a very interesting question because the way it has been presented, that makes this very interesting. So in this question, in order to get the sum of this series, we need to start pairing terms. So if I pair all the first terms together, and I get an infinite GP, 1 by 2, 1 by 2 square, and this will go up till infinity. Now, from the second terms, if I take 1 by 3 common, in fact minus 1 by 3 common, again I get 1 plus 1 by 2, 1 by 2 square till infinity. And from the next one, I can take plus 1 by 3 square common. So 1 plus 1 by 2 plus 1 by 2 square till infinity. And we can keep on doing till infinity. So if I do this, this is first GP that I have. So the sum becomes A upon 1 minus R. The second becomes in the similar manner A upon 1 minus R. Similarly, the third one also becomes A upon 1 minus R. And this will go till infinity. So if I observe this pattern, the first term becomes 1, the second becomes 1 by 3 into 2, the third becomes 1 by 3 square into 2. So not till infinity. Now if I leave the first term and focus on the second one, I can take again a 2 by 3 common. It becomes 1 minus 1 by 3, then plus 1 by 3 square till infinity. Again, in this second part, we can apply sum till infinity. So A upon 1 minus 1 by R. In this case, the R is nothing but minus 1 by 3. So if I apply the formula, becomes 2 by 3 into 1 upon 4 by 3. And if you simplify this, it becomes 1 minus 1 by 2 comes out to be 1 by 2. So now this is equal to alpha by beta. Then the value of alpha is 1, beta is 2. And if I want to get the value of alpha plus 3 beta, obviously it will come out to 7. Next, we are going to discuss a very special problem types that involves combining the problem or the concepts of AP and GP in one question. And let us start with it. Now, in this first problem, based on AP and GP combined concept, you can see that we can get X, Y, and Z by directly applying the formula for infinite GP. So if I want to find the value of X, it is nothing but A, A upon 1 minus R. Similarly, Y we can get is 1 upon 1 minus B, and Z we can get is nothing but 1 upon 1 minus C. Now, there are two ways to proceed forward. Either you can take the values of ABC and then solve this problem, or conversely, what you can do in this question is you can use the properties of AP. So now what we can say is, see, if A, B, and C are in arithmetic progression, then minus A, minus B, and minus C will also be in arithmetic progression. So if I am taking 1 minus A, 1 minus B, and 1 minus C, this will also be in arithmetic progression. And now if I take their reciprocal, so now if I am talking about their reciprocal, so if I am saying that this is equal to 1 by X, so 1 by X, 1 by Y, and 1 by Z will also be in arithmetic progression. So I have taken this 1 by A as 1 by X using this first equation, second equation, third equation. So C option becomes correct. Now let us look into the second question. In this second question, they are giving two conditions. One is A cube, B cube, C cube are in arithmetic progression, and then log of B to the base A to the base C to the base B are in nothing but GP. So first let us use the condition of GP because that will give you better insights. So if three terms are in GP, then B square is equal to AC. So log of A whole square will be equal to log of B to the base C and log of C to the base B. Now let us use base change formula. So if I use base change formula, it will be log of A by log of C whole square. This I can write this is log of B by log of C and into log of C by log of B. So this log B gets cancelled. And if I simplify it, it becomes log of A whole cube is nothing but log of C whole cube. That implies log of A will be equal to log of C, and that implies A will be equal to C. This is the first very important thing that we are getting in this question. Now, if you look into the AP condition, so if A is equal to C, then AQ will also be equal to CQ. Hence, this can only happen when A, B, and C become equal. Only then the AP condition will become true. Otherwise, it will not become true. Now, once we have gone from there to here, now they're talking about another series. Now, in this series, what they're saying is the first term is equal to this. So let us also write that another series that they're talking about. So if I take this alternative series, they have given the capital A is nothing but A plus. So I'm taking all as A, B and C also. So this becomes 6A by 3. So it becomes 2A. And if I want to find D, they have given as A minus 4 times A plus A by 10. Again, I'm taking A, B, C all equal to A. Once I do that, what I'm getting is nothing but, here it is 8. What I'm getting is minus 6A by 10 or minus 3A by 5. Now, once you have done that, what they're saying is if I take the sum of 20 terms, so sum of 20 terms will become 20 by 2, twice of A, and then A in this case was nothing but 2A. So let us take that also in consideration. So this will become 4A plus n minus 1, that is 90, and D is nothing but minus 3A by 5 is equal to minus 144. This is given to us. So now our task is very simple. Find the value of A and from there get the value of A into B into C. Right. So if I simplify this, this becomes 10. And if I divide by 2 on the both sides, this becomes 5. This becomes minus 222. If I multiply this 5 inside, this becomes 20A plus 19 into minus 3A will be equal to minus 222. And if I go further and simplify, this will become minus 37A. If I take both the terms, is nothing but minus 222. So A as a result comes out to be 6. Now what they're asking is what is the value of ABC? That would be nothing but 6 cube. And 6 cube is nothing but 216. You can see that there are two parts of the question. First part talks about GP and AP. So the GP condition gave us that A is equal to C. If I put that condition into AP, I get A is equal to B is equal to C. Then there is an alternate condition, and again another kind of series they are talking about in terms of capital and capital D. We apply the sum of the series and get the answer from there. Now this next question is very interesting. Let us look into it. So it talks about two positive numbers A and B, and it has been given that A, B and 18 are in GP. So if three numbers are in GP, we can write B square is equal to AC. So B square A into 1 by 18. This is the first condition. They're also saying that 1 by A, 10 and 1 by B are in arithmetic progression. So if three numbers in the arithmetic progression A, B, C would mean 2B is equal to A plus C. So 2 into 10 will be equal to 1 by A plus 1 by B. So you can getting this value as 20. This is 1 by A plus 1 by B. This is second condition. If you take the value of A and substitute it here, it will become 20 plus 1 by 18B square plus 1 by B. Now, usually answers of such questions are in integer only. So either you can solve the quadratic equation in 1 by B, and that is one valid way to do it, or you can be a little bit intelligent and think about what can be the fractional values of B. So I'm thinking in terms of something which is a multiple of 6 so that 18 gets cancelled out. So 1 by 6 I tried, did not work out. 1 by 12 is working out. So if I take 1 by 12, what you can observe here is by putting this value, your right hand side becomes 12 square by 18 plus 12. And if you simplify this first part becomes 12 into 12 by 18, 6 into 2, 6 into 3, 3 into 4. So 8 plus 12 becomes nothing but 20. So it gets satisfied. So this is hit and try, but it will make your calculations really fast. So once you are able to observe that, now let us find the value of A from here. So A is nothing but B square into 18. So if I write B square into 18, it will become again, okay, from the last part also you can guess, but let us do it. Here B square was nothing but 1 by 12 square, and into 18, if you do, the value of A comes out to be nothing but 18 by 12 square. We just did it, it is nothing but 8. So 12 into 12, 6 into 3, 6 into 2, 3 into 4, A becomes 1 by 8. Now we have got the value of A also, B also. Let us put in the expression that is given to us 16A plus 12B. So if I do this, if I put this into 16A, A is nothing but 1 by 8, and 12B, B is nothing but 1 by 12. Answer that I get is 3. Let us move towards another problem category, that is properties based on questions based on properties of GP. Now first I'm going to tell you in very short what are the important properties of GP that we are going to use in solving questions, and then systematically we are going to take recent pattern of questions based on it. So let us start with it. So first is regarding assumption of terms. So only assume terms. This is the first and the most important thing. Only assume terms if they are talking about product of the terms in the question. Otherwise it is a wastage of time. This is the most important idea. Now if you want to assume three terms, you can assume that as A by R, A and AR. So these are three terms. So you can see here the common ratio is nothing but R. For four terms, you will take A by R cube, A by R, AR and AR cube. So you again see here that now the common ratio is nothing but R square. So these are two, and in fact three very important ideas that you are going to use in solving problems. So next property is nothing, properties in which we have constants and operations with GP. So let us take an example in order to understand it faster. So if I take 1, 2, 4, what you can observe is if I add 5 to all the terms, it becomes nothing but 6, then 7, and then 9. So no more in GP. If I subtract 5, again you can see that this will become -4, -3 and -1, again not in GP. But if I multiply with 5, something magical happens. It becomes 5, 10 and 20. You can see that it is again in GP and the common ratio remains same. Only the first term has changed, has become 5 times, and the common ratio is still remains same. If I divide by 5, again what you will observe is this becomes 1 by 5, 2 by 5 and 4 by 5. Still you can see that the first term has changed, but the common ratio has remained same. So in addition subtraction, it will no more be in GP. For multiplication division, it will be in GP, just the first term will change. Now what happens if I take log? So if I take log, this becomes log of 1, log of 2, log of 4. So this one is 0 only, and this becomes log 2, and this can be written as 2 log 2. So what you can observe is now it has become an arithmetic progression. So if you take log on a GP, it becomes an AP. This is a very important thing. So we have done the first three properties. This was the first property, this was the second property, this is the third property, and the fourth property goes ahead and says that if I raise the numbers to the power, so if I do 1 square, 2 square, 4 square, now you can see that what has happened is the initial term, first term becomes a square and r square. The common ratio also becomes r square. So whatever power you are going to raise, the same power will also be taken by a and r. This is a very important idea. Now in the fifth part, what they're saying is if you multiply two GPs, let us say 1, 2, 4 and 3, 6 and 12. If you multiply both of these, what is happening is now their first term will be multiplication of both the terms, and their common ratio will also be multiplication of both the common ratios. Now next is the concept of means. Now in this concept of means, you can see we divide the property into two parts. The first part is how to take a mean of two terms. So if you have two terms A and B, their mean would be nothing but root of AB. If you have three terms like A, B and C, their mean would be A into B into C raised to the power 1 by 3. This is the answer. And now if I do the same process for n terms, I can write a similar result like A1, A2, A3, An. If I want to find that, I am going to multiply them till An and put 1 by n in the power. So this is the concept of means. So if you have to take mean in GP, this is what it means. Now there are some interesting properties to it. What are those interesting properties? The first thing is that if I am taking 1, 2, 4 and 8, so if I have to take the mean of all the terms, let us say 1 more 16. So if I take mean of all the terms, I will get the middle term. So I will get this term. If I take mean of 2, 4 and 8, still I get 4. If I take it for 2 and 8, I get 4. So you can see that equidistant terms are behaving, from the ends are behaving in the similar manner. This is a very interesting property. And the fourth is about inserting AMs, inserting GMs. So what we are saying is, let us say we have 1 and 8 and we want to insert two geometric means between them. This is exactly what we did with AP. So what does this mean now? A, G1, G2 and 8 are going to be in GP. So if I consider this phenomena, only thing that we do not know is R, and in GP, R is very important. So R we can find using the last term. So it becomes 8 into A into R raised to the power 4 minus 1. So you can see that the value of R cube comes out equal to 8 and R comes equal to 2. And this is important because now G1 would be equal to AR and G2 will be equal to AR square. You can put the values and get the answer. So this is the concept of inserting GMs. Now all of this has been summarized in the form of a table. So if you want to take a screenshot or take notes of this, it is very important. It will help you out. Now let us look into another problem category, that is questions based on geometric means. So I have already talked about these properties. Let us look into the question based on this idea. So question was asked in JEE 2020 that talks about m arithmetic means being inserted between 3 and 243 and 3 geometric means inserted between them, and they have given this condition and asked that what will be the possible value of m. So let us first insert the 3 geometric means. So there is 3 geometric mean 1, 2, 3 and then 343. So if I want to find the value of r, I can write 243 is equal to a into r raised to the power 5 minus 1. So if you solve this, this is 81 is equal to r raised to the power 4, r is equal to 3. So once you've got the value of r, now you can get the value of G2. So G2 is nothing but AR square, or A was 3 and R is also 3. So this becomes nothing but 27. Now let us go into the domain of arithmetic means. Now what they're saying about arithmetic mean is, if I have m arithmetic means, then 3, A1, A2 like this, then we will go till AM and then 243 will come. So if I want to find the value of D, it is going to be A plus M plus 2 minus 1 into D. So the value of D comes out to be 240 by M plus 1. This is the value of D we are getting. So if I want to find the value of the fourth arithmetic mean, it is going to be A plus 4D. A is nothing but 3. 4 into D is nothing but 240 by M plus 1. Now they are saying that this A4 is equal to nothing but 27. So let us equate this to 27. So 3 plus 4 into 240 by M plus 1. So 24 is equal to 4 into 240 by M plus 1. And you can see that the value of M plus 1 is coming out to be 40, or M comes out to be 30. So quite a simple question. If you know the concept, you can easily deliver this question. Now let us look into this next question. This next question is very intelligently framed on the properties of GMs and AMs. So now if we have three GMs between A and B, then we have A, G1, G2, G3 and then B. Fine. So I want to find the value of R. From here, B will be equal to A times R raised to the power 4. Or B by A is equal to R raised to the power 4. This is very interesting fact, because now we are going to use this to substitute in the option. So here, if I write this first, G1 is nothing but AR raised to the power 4. G2 is nothing but AR square raised to the power 4. G3 is nothing but AR cube raised to the power 4. And this is nothing but AR raised to the power 2 into AR square AR cube raised to the power 2. If we do this, now why are we doing this? Because once you do this, you realize that this term and this term comes out to be equal. It is bound to be. Using property also we can conclude that. So now we have A raised to the power 4, R raised to the power 4. 2 times A raised to the power 4, R raised to the power 8. And A raised to the power 4, R raised to the power 2. This came because these two are equal. You can calculate and check. So once you have done that, what you can observe is, from here, we can put the value of from R raised to the power from above. So it becomes B by A raised to the power 4, B square by A square. And A raised to the power 4, B cube by A cube. And if you do this very simple substitution, what you get from here is A cube B 2A square B square plus AB cube. And if I take AB common, this becomes A square plus 2AB plus B square. That can be written as AB into A plus B whole square. Now you can just look into the options and get the answer. How? Because we have property that if I take the mean of terms equidistant from the end. Now let us see this terms of arithmetic means. So this is what we have in terms of arithmetic means. So if I take arithmetic mean of A1, A2, it is going to be equal to AB. Arithmetic mean of AB. So A1 plus A2 by 2 will be equal to A plus B by 2. Or A1, A2 is equal to AB. So if I just look into my option A, I can directly get my answer. So option A, if I look into it, A1 plus A2 can be written as nothing but A plus B. And similarly, if you write G1, G3, it is going to become AR and AR cube. Again, you can see that this is coming out to be A square R raised to the power 4. R raised to the power 4 was nothing but B by A. You can see that this becomes AB. So again, if you check this option, and it is coming out to be A plus B whole square into AB, and this becomes wrong. You can check other options also, and apart, if you use the similar logic, the calculation is not very difficult. Now let us look into this next question. Quite simple question. What you have to do is just substitute the value and get to the answer. So now they have given this condition and all the terms are in geometric progression. So we can assume A and R in this question. So if I write the first term, this first condition, it becomes A into AR square into AR raised to the power 4 and AR raised to the power 6 and is equal to 1 to 1 by 1296. And we all know that 1296 is nothing but 6 raised to the power 4. If I write the terms on the left hand side, it is A raised to the power 4 and R raised to the power 12 is equal to 1 by 6 raised to the power 4. So A R raised to the power 3 will be equal to 1 by 6. This is first condition. Now if I look into the another condition that is given is A4 plus A2 is equal to 7 by 36. A2 is nothing but AR and A4 is nothing but AR cube and this is 7 by 36. Now, this value I can substitute. So AR plus 1 by 6 is equal to 7 by 36. So AR comes out to be 1 by 36. Now if I divide both of these, I get the value of R square and that is nothing but 6. So these are the three informations available to me. Now let us see what they have asked from us. So what they have asked from us is nothing but find the value of this expression, that is A6, that is AR raised to the power 5, A8, AR raised to the power 7 plus AR raised to the power 9. Okay, so if I take AR cube common, it becomes R square, R raised to the power 4 and R raised to the power 6. Now AR cube value we already know. AR cube is nothing but 1 by 6. AR square, R square is 6, so this becomes 6, this becomes 36 and this becomes 6 cube, so 216. If I simplify this, this comes out to be 43. Now let us look into another question based on similar type of concept. Now what they are giving this question is 1 by x, 1 by y, 1 by z are in arithmetic progression. What would that mean is 2 by y will be equal to 1 by x plus 1 by z. This condition we know. So if I simplify this, this is nothing but x plus z by xz. This is what we will get. Another condition is given that x, root 2 y and z are in geometric progression. That would mean root 2 y whole square will be equal to xz. So 2y square is equal to xz. So I can use this condition and substitute it here. If I do that, 2 by y is equal to x plus z is equal by 2y square. So what we get is nothing, x plus z is nothing but 4y. Now apart from that, they have given us another condition. What is the another condition? Let us look into this. This condition talks about a relation between xy, yz, zx. If I divide this x by z on the left hand side, it becomes 1 by z plus 1 by x plus 1 by y is equal to 3 by root 2. Now this is a very interesting condition because see again from this first condition, I can substitute the values here and this becomes 2 by y plus 1 by y is equal to 3 by root 2. We can cancel out these 3 and y becomes nothing but 2. Once y becomes root 2, we can substitute and get the value of x into z. That is nothing but 2 into 2. So xz is nothing but 4. And also we can get the value of x plus z, that is nothing but 4 into root 2. Now in order to solve this, the solution is not very difficult. We can substitute the value of z here. So z is nothing but 4 by x. X plus 4 by x is equal to 4 root 2. So x square plus 4 is equal to 4 root 2x, or x square minus 4 root 2x plus 4 is equal to 0. And once you solve this quadratic equation, the value of x comes out to be 2 root 2 minus 2. From here, the value of z comes out to be 2 root 2 plus 2. Now let us go into the question part. Question says that find this value. So what they're asking us to find is nothing but 3 times x plus y plus z whole square. So we already know the value of x now, 2 root 2 minus 2. Y was nothing but root 2 and z comes out to be 2 root 2 plus 2 whole square. And if I do this, what we get is 5 times root 2 whole square into 3. This, if you calculate, comes out to be 150. It's not a very difficult question. And what you need to do is use the same condition multiple times to get to the answer. Now, this is the very interesting question. This question talks about that the arithmetic mean and geometric mean of pth and q term of a sequence this. Now, if you look into this sequence, the common ratio is nothing but minus 1 by 2 and a is nothing but minus 16. So this is nothing but a GP. Now they are talking about that the pth and qth term. So the pth term would be nothing but a r raised to the power p minus 1 and the q term would be nothing but a r raised to the power q minus 1. So now the two roots are nothing but am and gm of this. So it is a little bit complicated there. Okay, so an easy way to go about this would be to find the roots and work backwards rather than going in the forward direction. So if I find the roots, x would be equal to 9 plus minus root of b square, that is 81 minus 4ac by 2a. If I do that, this becomes 9 plus minus 1 by 8. You can see that one of the root comes out to be 10 by 8 and another root comes out to be nothing but 1. Now see, the smaller root is going to be the GM and the greater root is going to be the arithmetic mean, because AM is always greater than or equal to GM. So I will have to consider this root. So if I consider this root, what they are saying is the square root of a r raised to the power p minus 1 into a r raised to the power q minus 1 should be equal to 1. So if I do this, what you can observe from here is nothing but a square r raised to the power p plus q minus 2 will be equal to 1. So now a square here would become nothing but 16 square. And this is minus 1 by 2 raised to the power p plus q minus 2 equal to 1. If you simplify this, very simple idea, so you will get the value of p plus q as nothing but 10. Quite simple to do. Now the 10th problem type is nothing but based on AM is greater than or equal to GM. So what is this idea? Idea says that if you have two terms, A and B, then for those two terms, the condition is both of them needs to be positive. AM is greater than or equal to GM cannot be applied for negative term. This is very important. So AM becomes A plus B by 2 and GM becomes root of AB. I can also apply the similar idea for n terms. If I consider A1, A2, A3 till AN, still the idea remains true. Condition is they needs to be positive. So if you have A1 plus A2 until AN, by n, this is going to be greater than or equal to nothing but A1, A2 multiplication till AN raised to the power 1 by n. Except the equality comes when the terms become equal. So this equality will come when A is equal to B. This equality will come when A1 is equal to A2 up till AN. And then at this point, the AM will take its minimum value and the GM will take its maximum value. And see, the important idea is not just this, the concept of AM is greater than or equal to GM. The hint in the question will come from terms given positive. So this is usually the hint in the question which will give you the way forward to apply this idea. Now let us see through question how to apply this idea. Now this idea has been asked in JEE exam in 2-3 different ways. Let us try and understand that. So the first way of applying this idea is nothing but something like a weighted mean kind of a situation. Like in this question, if you look into it, what they're asking is a raised to the power 5 b cube c square d. So what we are saying is if I take 5 a by 5 terms, so a by 5, a we are splitting into 5 different parts, so a by 5 we are taking 5 times. And then similarly b by 3 3 times, and then c by 2 2 times, and d 1 time. So these are total, if you look from here to here, there are total 11 terms. And now in this 11 terms, since all of them are positive real numbers, this is the hint in the question, we can apply AM is greater than or equal to GM. So if I do that, a by 5 plus a by 5 5 times plus b by 3 plus b by 3 plus b by 3 plus c by 2 plus c by 2 plus d by, since there are total 11 terms, this is going to be greater than or equal to a by 5 raised to the power 5, c by 3 raised to the power 3, sorry, b by 3, and c by 2 raised to the power 2 into d raised to the power 1 by 11. Got it. Once you have done this, your life becomes very easy because whatever is written on the numerator, this 5 a by 5 will become a, 3 b by 3s will become b, then c and d divided by 11 is always greater than equal to a raised to the power 5 b cube c square into d by nothing but 5 raised to the power 5, 3 raised to the power 3, 2 square raised to the power 1 by 11. See, now the numbers are given in such a manner that a plus b plus c plus d is equal to 11. And this will benefit us while solving the problem. And now if I put this value as 11, so this 11 by 11, a raised to the power 5 b cube c square d by 5 raised to the power 5, 3 square, 3 cube, 2 square raised to the power 11 will be smaller than or equal to 1. So the maximum value of a raised to the power 5 b cube c square into d, this is always smaller than equal to 5 raised to the power 5, 3 cube and 2 square. So the minimum value is this. Now what they've given is 5 raised to the power 5, 3 cube, 2 square should be equal to 3750 into beta. Now this can be easily solved. If you factorize it, the value of beta comes out to be 90. Now in this question, they are playing with the same idea but in slightly different manner. Now let us see that. Now in this question, what they have given the question is x into y is greater than 0. This is the hint to apply m is greater than equal to gm. Now since they are talking about x cube y square 3x to y, it makes sense that we take 3x's and 2 y's and then apply m is greater than equal to gm. So x plus x plus x plus y by 5 is greater than equal to x cube y square raised to the power 1 by 5. Okay, so if I look into my left hand side, it is 3x plus 2y by 5 is greater than equal to x cube y square value they have given in the question as 2 raised to the power 15. Let us substitute this value. So what do we get is 3x plus 2y by 5 is greater than equal to 2 raised to the power 3, or 3x plus 2y is greater than 8 into 5, that is 40. So quite a simple question, but this idea of weighted, same things getting repeated again, has been asked in JEE twice. Now again, a very simple question. Now if you look into a raised to the power x, obviously the quantities are positive. So again, we can apply m is greater than equal to gm between a raised to the power ax and another quantity is a raised to the power 1 minus a raised to the power x. So we can write a into a raised to the power x plus a into a raised to the power 1 minus a raised to the power x by 2 is greater than equal to a raised to the power x and into a raised to the power 1 minus a raised to the power x raised to the power 1 by 2. Okay, so if I do that, I get my fx on the right hand side divided by 2 is greater than equal to, if I multiply, becomes a raised to the power 1 by 2. So my fx is always greater than equal to 2 root a. So my answer becomes fourth option. Now again, a very conceptual and simple question. They are asking the minimum value of this function. Again, the terms involved are both positive, so a greater than equal to gm can be applied. So now we already learned this, that if we have two quantities a and b, then a plus b by 2 is always greater than equal to root of ab. So the minimum value of this part will come when a is equal to b. So if we have two terms, in place of a we have 2 raised to the power sin x, in place of b we have 2 raised to the power cos x. Divide by 2 is always greater than equal to root of 2 raised to the power sin x into 2 raised to the power cos x. Now the minimum value of this left hand side will come when 2 raised to the power sin x becomes equal to 2 raised to the power cos x. And that is going to happen when sin x is equal to cos x. So there are two values possible. One of the possible values is this happens when it becomes 1 by root 2. Another value then it is possible is minus 1 by root 2. Okay. So if I consider my first value, the answer comes out to be 2 raised to the power. So for our function, 2 raised to the power sin x plus 2 raised to the power cos x. So one answer comes out to be 1 by root 2 plus 2 raised to the power 1 by root 2. So that is nothing but 2 into 2 raised to the power 1 by root 2, or 2 raised to the power 1 plus 1 by root 2. And another answer of the same question will come when the sin x and cos x becomes minus 1 by root 2. So 2 raised to the power minus 1 by root 2 plus 2 raised to the power minus 1 by root 2. So it comes out to be nothing but 2 raised to into 2 raised to the power minus 1 by root 2, or 2 raised to the power 1 minus 1 by root 2. Now this is a more relevant answer because we are looking for a minimum value. So our answer becomes 1 minus 1 by root 2. Now let us look into one last question based on similar idea. What you can look into this question is, this is like mixture of 2-3 concepts. So one, they are saying that these 3 terms that are given to us are nothing but in AP. So 2 times fx should be equal to nothing but 2 raised to the power 1 plus x. 1 minus x, this is one term, first term, and the last term. So what we are trying to say is 2b is equal to a plus c. So this becomes 3 raised to the power x, 3 raised to the power minus x. Now, next what they are saying is they are talking about minimum value of this fx. Here our aim is greater than or equal to gm will come into place. Because what we can say is minimum value will come when both of these are minimum. Now, for some common value of x. So now if you look into this first 2 raised to the power 1 plus x, this will take minimum value of this is equal to this part. And this can only happen when 1 plus x is equal to 1 minus x. So you can see that x comes out to be 0. Similarly, if for this value, you can see that 3 raised to the power x and 3 raised to the power minus x will also become same. And hence, this will also take minimum value. So what we can say is the minimum value will arrive when x is equal to 0. So this becomes 2, 2, 1 and 1. So the value of fx, that is minimum, comes out to be. Now let us look into next problem type. This is the 11th and the last problem type. These are the questions which are based on the combination of properties of log and sequence. Let us look into one of such questions. Now in this JEE 2020 question, you can see that there is log and infinite GP involved in the same question. So if I look into this question, what I can do here is basically in the power inside the log, we can apply the formula of infinite GP. It comes out to be a upon 1 minus r. And if you simplify, it is 0.16 raised to the power log of 2.5. And this, if you simplify, becomes 1 by 2. Now you can use the ABC formula. Let me remind you what is ABC formula. So if we have a log c to the base b, then this is equal to c log a to the base b. ABC formula. I call this as ABC formula. This is a very common result. So if I use this, this 1 by 2 will come below and this 0.16 will go inside. Now, why are we doing this? Because now let us focus on this part of the problem. Okay, that is log, because now we are going to use properties of log. We have already used one. We are using it more. So if I look into this part, what you can say is 2.5 can be written as 5 by 2. And 0.16 can be written as 16 by 100. If I divide by 4, it is 4 by 25. So you can see that this becomes log of 2 by 5 whole square. This is 5 by 2. We can further simplify and write this as 5 by 2 raised to the power minus 2 to the base 5 by 2, and the answer comes out to be minus 2. So what was written in the power, that has now become nothing but minus 2. So this becomes 4. So the answer to this question comes out to be 4. Now let us look into this next question. Again, it tries to combine both the ideas. Let us see. So in this question, if I start from this part, that they have given this arithmetic progression whose first term we know is nothing but 3 and the common difference is nothing but 1 by 2. So if I want to write the second term, it is going to be a plus d. So this is going to be 3 log x to the base y. Okay, so if I take the things on the left hand side, it is going to be 7 by 6 is equal to log of x to the base y. That can be written by base change formula as log x by log y. Fine. In the similar manner, if I look into the third term, it is going to be 3 plus 2 into 1 by 2 is equal to nothing but 3 log y to the base z. And again, if I simplify, this is 4 by 3 is equal to log y by log z. And again, if I look into the third part or the last term, it is 3 plus 3 by 2 is equal to 7 log z to the base x. And if I again simplify, this would become 6 plus 3, 9. 9 by 14 is equal to log of z by log of x. Now, if you look into this, your log x, log y, log z can be written as in the ratio of nothing but 14, and in the base of here we can write as 12 and here nothing but 9. Now once I get these ratios, it is very simple that if I want to assume, I can assume this equal to, let us say, nothing but k. So x would be nothing but 10 raised to the power 14k. Y would be nothing but 10 raised to the power 12k, and z would be nothing but 10 raised to the power 9k. Once I've got these results, I can use and substitute this in the first part of results that were given to me. So you can see that now if I replace x, so this becomes 10 raised to the power 14k pq square. This would be equal to 10 raised to the power 12k qr, and this is equal to 10 raised to the power 9. This was 9, yes, 9k p square r. So if you compare the powers, what you're getting is 14 pq square is equal to 12 qr is equal to 9 p square r. If I simplify the first part, it becomes 7 times pq is equal to 6r, and one more result is given, r is equal to pq plus 1. So pq can be written as r minus 1. So from here, if you find the value of r, it comes out to be 7. And now I have two more results with me. What are two more results? If I compare the other two parts, what you get is 12q is equal to 9p square. And again the value of pq is equal to r minus 1 is given as 6. From here, if you solve, your p comes out to be 2 and q comes out to be 3. And if you find the value of r minus p minus q, it comes out to be 7 minus 2 minus 3. That is nothing but 2. D option. So let us move towards this last question of our discussion. See, in this question, there are two parts of the question. One is based on determinant, another one is based on logarithm. So first, let us see the logarithm part of it. What they're saying is these three terms are in arithmetic progression. So what we can do is we can write 2 times log of 4 raised to the power x minus 2 is equal to nothing but 1 plus log of 4 raised to the power x plus 18 by 5. If I apply the properties of log, this can be written as log of 4 raised to the power x minus 2 whole square. And this 1 also can be written as 10 to the base 10. So here base 10 have not written, but it is assumed that the base is 10 only. So log of 4 raised to the power x plus 18 by 5. If I simplify, the left hand side becomes 4 raised to the power x minus 2 whole square. And the right hand side becomes 10 times 4 raised to the power x plus 18 by 5. And now if you compare whatever is inside, what you get is 4 raised to the power x minus 2 whole square is equal to 10 into 4 raised to the power x plus 18 by 5. And from here, it becomes a quadratic equation in 4 raised to the power x. Now I am writing 4 raised to the power x as t becomes 10 times t plus 18 by 5. And if you do this, t square minus 4t plus 4 is equal to 10t plus 18. And you get a quadratic equation t square minus 14t minus 36 plus 4 equal to 0, or t square minus 14t minus 32 equal to 0. So from here, the valid value of t that you get is nothing but 16. And 4 raised to the power x is equal to 16. That means x will be equal to 2. All right. So we have solved this. Now this is the first part of the question. In the second part of the question, we'll deal with this determinant. And this is quite simple part because you have to just put the value. So this becomes 2 into 3 by 2. This becomes 1. This becomes 4. 1, 0, 2, 2, 1, 0. And this becomes a very simple determinant wherein the first row becomes 3, 1, 4, 1, 0, 2 and 2, 1, 0. And if you simplify this, the answer comes out to be 2. If you like this video, you will also like Pragbee's unique approach to teaching students or guiding students for the last mile journey. So if you are a student who has been preparing for 2 years and going to write this exam in 2024, this is one of the best ways and platforms that you can prepare with. Unlike other crash courses who focus on teaching 100% syllabus in just 2 to 3 months, which a student took 2 years to prepare, we have a different way to approach the problem. This process works on 3 very specific steps. In step 1, we start from you. What exact preparation have you done in the last 2 years, last 1 year, last few months? And what is the minimum amount of effort, areas, concepts and problems that required to be prepared to get a very good college from JEE Mains? In step 2, based on this customized plan that was prepared based on your strengths and weaknesses and the minimum path of least resistance that you can take to get into a very good college, we align you a one-on-one faculty, a faculty who is going to teach you as a student, keeping your needs into mind, where you are getting stuck in a topic, what kind of problems you cannot solve, and how to solve those problems in a very efficient and smart manner and convert that topic into tangible marks in JEE Mains. In step 3, we attach you to a test series, a testing platform where you can test yourself for each and every topic that you're preparing. You can write full syllabus tests and get an understanding that how this program is working for you, wherein the faculties can again sit with you and customize the plan based on your needs so that your score is getting maximized in JEE Mains exam. Using this program, Ashish was able to maximize his score in JEE Mains and JEE Advanced and was able to get into IIT Madras Mechanical in just a matter of 3 months. If you are one of those students who think that he has got the potential, who can make it, and he wants to have a smart and efficient approach at this point of time, which can maximize his or her result in JEE Mains exam, you can apply for this program in the link given in the description, and somebody from my team will get in touch with you and help you out. See you until next one.